In some parts of the country, there is a lack of water, and there's a lack of water resources, drinking water, and so utilities are faced with finding alternative water supplies. Potable reuse creates a climate-resilient, local, and sustainable water supply. When you're transforming municipal wastewater into drinking water, there's a vast array of chemical contaminants and microorganisms and pathogens in the water that need to be removed. The treatment technologies to produce high-quality drinking water are already there, but the monitoring techniques is where we really need to advance the science. It's impossible to measure all individual contaminants in water samples, so an indicator compound is used. An indicator compound is an individual chemical that represents a broader group of potential chemical contaminants with like characteristics. So the fundamental concept is that an indicator compound has similar properties to a larger group of chemicals that could be potentially harmful, and you can use those indicator compounds to assess process treatment performance. Real-time monitoring gives utilities confidence that public health is being protected at all times, and in turn that also gives the consumer confidence that public health is protected. I think that the science of the monitoring and real-time techniques will drastically increase. We'll be able to assess risks much more confidently, and in turn that will increase the consumer's confidence in the water that they're drinking. I love research and development because I think that it's creative. It brings an element of creativity to engineering that's not necessarily there all the time. I started my graduate research assistantship with Greywater Reuse, which is a non-potable reuse application, and when I got to CDM Smith, I started working in potable reuse, and that's really the way that the field is advancing. More utilities are turning to potable reuse as water supplies are being challenged, and so I'm really passionate about making potable reuse work.